Hello everybody, this is Dr. Nurbat Shah. Today's lecture is about measure of position, and we will be talking about mode as well. So first thing is what is the motivation behind studying measure of position? So one of the most used measure of position is known as median, and then the other ones are quartiles. We also can talk about deciles and percentiles as well. So median is the most informative measure of central tendency, and that is most important in case of skew distributions or distributions which have outliers. Keeping in mind in this case at the moment distributions basically means that given data, or we may call it population. So if we have a skewed distribution, or if we have a data distribution with some outliers, then in that case you know that outliers are more troublesome, create troubles in computing means. So in outliers case it's most important to go for median. Okay. For example, the median is often used as a measure of central tendency for income distributions, which are obviously they are generally highly skewed. Now, what is median? Let's define median, and then we will be talking about how do we compute median in different type of data. So the first step for computing median is we need to arrange the given data either in ascending order or in descending order. It doesn't matter whichever it is, and then we will be looking for an observation from that distribution, or maybe outside the distribution, which divide the given data, the distribution, into two equal parts, and that the observation that would be known as median. In other words, we can say that if we have a median, let's suppose that is denoted by M, then 50% of the data will be lying below M, and 50% of the data would be lying above median. Right. So how do we do that? Let's talk about the method which is used for finding median. The median in case of raw data, if we have raw data, so how would we find a median? So the steps are what? The first step is you need to arrange the data. It could be either in ascending order or descending order. Usually we favor ascending order. So once you have arranged the data in ascending order, then you would count the number of observations. Let's suppose n represents the number of observations, or that represents the size of distribution. Okay. Now we consider two cases. What about dividing this data into two parts? So we divide n by 2. So now n by 2, whether this n by 2 is integer or it's not integer. So if n by 2 is not integer, which basically means if n is odd, in that case n by 2 least integer function, least integer basically means you have to consider smallest value which are greater than or equal to n by 2. So we will be picking the least integer value of n divided by 2, right, and the observation at that position, n by 2 least integer position, that will be the median. It will tell the position of the median, and observation at that position will be the median. Right. But if n by 2 is an integer, obviously in that case we don't have one median, there would be two medians, because we'll be looking for midpoint. So we talk about n by 2th position and n by 2 plus 1th position. That would give you the average two values or two positions for the median, and the median would be the average of these observations. Okay, let's do an example for it. Let's suppose we have marks of 9 students, and we are interested to find the median of that given distribution or given data. So those observations are given as 45, 32, 37, 46, 39, and so on. That is the given data. The first step is we have to convert this data, or we have to arrange the given data in ascending order. So we have 32, 36, 36, 37, 39, 41, 45, 46, 48. And now the number of observations in this case are 9. So 9 by 2, which is 4.5, that is not an integer. Okay, so if it is not integer, now we would take the least integer value. What does it mean? 9 by 2, least integer, 9 by 2 is basic 4.5. So least integer value for 4.5, that is 5. We will take the next value. You see, that's the smallest integer among the integer greater than or equal to 4.5. So 5 is what, that's the position of the median. So we will be considering the fifth observation, that is 1 is 32, 36, 36, 36, and then we have 39. So this is the median. You see, 39 is the median of this data, which is the fifth observation, obviously. Okay, if we have the number of observations for which n by 2 give you integer, so how do we do that? Let's suppose you just add one more student whose marks are 50. So the first step is what? You have to arrange the given data in ascending order. Now the number of observations are 10. Okay, and once we arrange that as we did in the previous example, then we find n by 2. Now n is 10 in this case, so n by 2, that is 10 by 2, which is 5. Now 5 is an integer, so we will be considering fifth observation and the next one. So we take these two observations. The fifth one is 39, whereas the sixth one we will be taking the next one, that is 41. So the average of these two, that would be basically what? That would be the median. So we take 39 plus 41 divided by 2, that is equal to 40. So median in this case, when number of observations are even, or we say this n by 2 is an integer. So in this case the median would be 39 plus 41 by 2, which is equal to 40. So median is 40. Okay, what would happen if we want to find, or we have a group ungrouped frequency data, right, and we want to find a median from that data? So I'm going to explain this by using this example. Let's suppose we have these are the number of assistants, and these are the corresponding frequencies. Okay, so we need to find median for this 50 size data. The first step is what? You would first you need to find the cumulative frequencies. I hope everybody knows how to find cumulative frequency. The cumulative frequency can be found, as you see, 3 is the first frequency, then we add 4 to 3. So 3 plus 4, that is 7, is the next cumulative frequency. Then we add 7 to 6, which gives you 13, would be written here, and then 13 plus 7, 20, 20 plus 10, 30, 30 plus 6, 36, and so on. This last cumulative frequency should be the total number of frequencies, or total sum of the frequencies. Once we have constructed this cumulative frequency column, what would we do? We would again find n by 2. Now n by 2, you would check whether n by 2 is integer or it is non-integer. Okay, now n by 2 in this case, that is 50 divided by 2, which is 25, and this is integer. Now you would locate this 25 in the cumulative frequency column. Do you see 25 in this column? The answer is no. There is no 25 which is written in this column. So what do? We just go to the region, or to the position where this 25 would lie. So that would be between 20 and 30. The red arrow shows that position. Okay, it is between 20 and 30. So what would you do? We would consider 30. We don't consider 20. It is between 20 and 30. So all the time you will take the next cumulative frequency. Okay, so 30, and then we take the observation in front of 30, which is 4. So 4 would be the in this case, that is the median. In front of 30, that is 4. So the median would be 30. And what would happen if this number was present in the given column? So let me explain that in next example. But if n by 2 is not integer, if it was not integer, let's suppose if this was 49, it was not 50. So 49 by 2, which is not integer now, and then simple see whether this observation, this value, this n by 2, a least integer value, is it lying in the cumulative frequency column or not. If it lies, the observation in front of that, let's suppose if it was 30 or 20 something, the corresponding number 3 would have been a median for that. If it was between 20 and 30, what we had in this example, so again you would take the next one, and the observation in front of that cumulative frequency would be the median. Okay, but in case of n by 2 integer, and the integer lies, this quantity lies in the cumulative frequency column, that's a bit tricky. So let me explain that with an example. Let's suppose we consider almost same example, just increase the frequency. Okay, now we are having frequency for 9 to be 11. The first step is same. You would introduce cumulative frequencies. Okay, you know how to find that. I explained that. You would say 3, and then 3 plus 4 is 7, 7 plus 6 is 13, plus 7 is 20, and so on. Now in this case, the total frequency would be 60. Okay, so now what do? We would simply find n by 2. Now n by 2, that is 30, and which is integer. Okay, so n by 2 is 30, that is integer. Now it would locate this 30 in the cumulative frequency column, which is now here. It is already present in the cumulative frequency column. Okay, so what would you do? Now we would just look for the observation in front of 30, which is 4, and the next one you would consider these two. Now in previous case, when it was not in the cumulative frequency column, so we simply took the next one, and observation in front of that was the median. But if it is in the cumulative frequency columns, you will take an observation in front of that and the next observation, and you would find the average of those two numbers. So in this case, you would see the median would be 4 plus 5 divided by 2, this 4 and this 5. So 4 plus 5 divided by 2 would be the median. The same idea could be extended towards quartiles as well, which I'm explaining in a while. Okay, what would happen if you have group data? Okay, so in this case, the first step is you have to introduce class boundaries if class limits are given. If already we had a class boundaries, so they need to convert or to introduce class boundaries if you have already class boundaries. But if you have class limits, then you need to introduce class boundaries. Okay, that's the first step. Step 2, you have to include cumulative frequency column as well, what we have done in case of ungrouped frequency data. So cumulative frequency column is important. Then you would find n by 2, okay, where n in this case will be sum of the frequencies, irrespective of whether n by 2 is integer or non-integer. And you have to locate that n by 2 in cumulative frequency column, and that would give you, again the concept is same. If this quantity n by 2 is present in the cumulative frequency column, then the class in front of that cumulative frequency would be the median class. If this quantity is between two cumulative frequencies, then you would take the next one, the larger cumulative frequency, and the class in front of that would be the median class. So once we have a median class, there is a formula to find median, and the formula is given by L plus H by F into n by 2 minus C, where L is the lower boundary of median class, H is the class width, F is the frequency of the median class, whereas C is the cumulative frequency of previous class or preceding class. Okay, keeping in mind, and then putting all these values in this formula to get median for the given group data. Let me explain this by using example. Let's suppose we have this data 30 to 39, there are 8 individuals, 8 students, 40 to 49, and then we have 50 to 59. So we will be having frequencies plus their corresponding groups. But you see, the data is in classes, they are not given in boundaries. So the first step is what would you do? You would introduce class boundaries. You don't need midpoints, obviously. So you would introduce what? Class boundaries first. It is 29.5, 39.5, 39.5 to 49.5. Then we have frequencies as well, and you would introduce cumulative frequencies as well. So that is 8, and then we have 8 plus 87 is 95, 95 plus 190, and so on. The total frequency would be the last cumulative frequency. Now, the next step is what? You would first find n by 2, irrespective of even, odd, or integer, non-integer. So it is 452.5. Now you would locate this quantity, this number, in the cumulative frequency column, and you see that is between 285 and 589. So you would pick 589 as cumulative frequency. Then in front of this number, the class is what? That is 59.5 to 69.5. So we get the median class. This is the median class. 59.5 to 69.5 is the median class. So once we have median class, you would use this formula which is explained earlier. So L in this case is the lower bound. Okay, H is the class width, which is this one minus this one. So 10 in this case is the class width. F is the frequency of the cumulative of the median class, which is 304. So we will put H 10 by 304, n by 2, that is 452.5. whereas C would be the cumulative frequency of preceding class, which is 285. So you simply put 285 here. When you simplify this, this would give you 65. So median of this data is what? That is 65. Okay, sometimes we have many groups in the data. The group lies over different classes, different groups. So we divide those classes into more than 2 groups, and for that purpose we use quartiles, we may use deciles, we have percentiles as well. The basic concept of quartiles, percentiles, and decile is exactly same what I explained in median. I am explaining quartiles only, and I presume you will be able to extend the same concept towards deciles and percentiles. Okay, so what do we do in quartiles? In quartiles, basically we arrange the given data in either ascending order or descending order, and then we divide the given data into 4 equal parts by using 3 divisors, and then each divisor is called quartile. Okay, and the 3 quartiles, which are usually denoted by Q1, Q2, Q3, keeping in mind Q2 is representing a median, and Q1 that is known as lower quartile or first quartile, where Q3 that is the upper quartile or third quartile. Q2, as I mentioned earlier, that is the median. So below Q1 there will be 25% data falls, whereas after Q3 there will be 25% data, whereas below Q3 there will be 75%, and above Q1 there will be 75%, whereas below and above Q2 would be 50%, because that is the median. Okay, they are very useful in various cases. They can help you understand your data set, central tendency and variability, and even though it will help in finding outliers as well. And this is also important in box plots as well, right? To draw a box plot, so we need to know what are the quartiles or vice versa. Okay, the median is Q2 in this case, and it splits the data set in half, and it's a handy measure of central tendency for skewed distribution, as I explained earlier. Now, how do we do that? How do you find quartiles from raw data, and then from ungrouped frequency data, and then from group frequency data? For quartile 1, what do? We will be simply consider n by 4 instead of n by 2, and we would say if n by 2 is not an integer, then we will take the least integer value of n by 4, and at that position the observation would be the first quartile. And if n by 4 is an integer, in that case we will be taking 2 values, that's n by 4th and n plus 4 by 1th observation, and average of those 2 observations will be the first or lower quartile. Whereas for second quartile, which is the median, that's already discussed. Now for third quartile, what do? We consider, instead of n by 4, we would consider 3n by 4. If it is an integer, then the least integer value of 3n by 4 observation would be the first quartile. But if it is integer, 3n by 4 is integer, then we will be having 2 positions for the median. That's the 3n by 4th position and 3n by 4 plus 1th position. And the observation at these positions, you would take the average of them, and that would give you the third, or we may call it upper quartile. Let me explain this with example. So if we have 9 observations as discussed earlier, and then we know 9, you have to put this in order first. We are using, as I said earlier, ascending order for the given data. Now if you find 9 by 4, okay, 9 by 4 is not an integer again. Okay, so we will take the least value n by 4, which is 9 by 4, it's 2 by 2, 2.2. So this least value or least integer value for this 2.2 would be 3. It means you would take the third observation in the arranged data, which is 36. So 36 would be the first quartile. Whereas for Q3, we will consider 3n by 4. 3 multiplied by 9 is 27 by 4. Again, it is not integer. So if you take 27 by 4, that is 6.7. So you would consider the least integer value, which is 7. Now you will count the number 7. So 1, 2, 3, 4, 5, 6, 7. It is 45. So the third observation, the third quartile would be the 7th observation, which is 45, and that is Q3. I'm sorry, it's a typo. This Q3 is not Q1. So the first quartile in this case, when we have 9 observations, is 36, which falls at third position, whereas the third quartile is 45, which falls at 7th position. Okay, what would happen if we have n by 4 or 3n by 4 as integer? So then what do we do? Let's suppose we consider 12 marks of 12 students instead of 9, because we want to have a number which is divisible by 4. Okay. In previous case, we considered 10 observations because 10 is divisible by 2. 12 is also divisible by 2, so you can take 12 as well. It doesn't matter whatever you want to take. In this case, we take what? We take 12, because 12 is divisible by 4. 10 is not divisible by 4, so we take 12 observation. Now if you find n by 2 after arranging this data in ascending order, and you see n is 12, so n by 4, that will be 12 by 4, which is 3. Now 3 is an integer, so you would consider third and fourth term in the given data. So that is a third term, this is the fourth term, and then you would take average of that. So we will take 36 plus 37 divided by 2, which gives you 36.5. And if you find 3n by 4, 3n by 4 is also the integer, because 3 multiplied by 12 divided by 4 is 9. So we have 9, that is also an integer. So you would consider 9th observation, and 9 plus 1th, that is the 10th observation. And then we take average of that to get Q3. So 9th observation is this is 5th one, 6, 7, 8 and 9. So 48, and the next one would be 50. So we take these two, average of these two observations, 48 and 50, which is 49. So these are the two observations which are responsible for the median. So this quartile 3. So quartile 3 in this case will be 49. Okay, what would happen if we have again ungrouped frequency data? Okay, in the previous example we discussed, the basic concept is same as I said. You will be simply going, if you are finding quartile 1, you would divide this by what? By n divided by 4. So 50 divided by 4, which is again not an integer, so we take least integer value n by 4, that is 13, and 13 is here. Okay, so you see 13 is there. So we will be basically picking the observation in front of 13, which is 2, and so first quartile would be 2. If you want to find third quartile, so you will take what? That is 50 multiplied by 3 divided by 4, which is also not integer, and you would simply be able to find third quartile. The same steps can be repeated for finding Q3. Okay, what would happen in case of group data? The concept is almost same. We simply take the same steps what we have discussed in case of median. The only difference will be in the formula, and that would be replaced. For the first quartile, you would replace n by 2 with n by 4. For third quartile, you would replace 3n by 2 by n by 2 by 3 n by 4. Okay, that is this concept is same. So the steps are what? You have to introduce class boundaries as we did in case of median. You would include cumulative frequency column as well. Then you would find Jn by 4 for Qj. Qj means if you are finding Q1, you would take n by 4. If you are finding Q2, you will be taking 2n by 4. That is median. And if you want to find Q3, so that will be 3n by 4. And where j is what? That's 1, 2, 3. N is sigma f. And then again, you will be looking for this quantity in the cumulative frequency column. And if it is there, then the class in front of that will be the median quartile class, whichever, if you are talking about first quartile or third quartile. So you have to locate this quantity Jn by 4 in cumulative frequency column to find the quartile class using the following formula to find the quartile. You see, in previous case it was simply n by 2, but now it becomes Jn by 4, where j is 1, 2, 3. So for first quartile it would be n by 4. For second quartile, which is obviously median, to be n by 2, whereas for third quartile you would take 3n by 4. Okay, that's the formula for it, where L is the lower bound, H is the class width, F is the frequency, where C is the cumulative frequency of the previous class or preceding class. Let's consider the same example we discussed for median. Okay, we need to find quartiles for the distribution of the examination. So first step is what? You would introduce class boundaries, which are 29.5, 39.5. Then you will be taking cumulative frequency column, and you know how to find these cumulative frequencies. Then you would find, now for first quartile, you would find n by 4, which is 905 divided by 4. That gives you 226.25. And now looking for this value in the cumulative frequency column, which is between 95 and 285. So you will be considering 285 cumulative frequency, and the corresponding class would be then what? That is 49.5 to 59.5. Okay, and then putting all these values, that's our first quartile class, and then by using formula, it is L plus H by F n by 4 minus C, and that will give you 56.4. So the first quartile in this case would be 56.4. The same thing can be done if you simply compute 3n by 4, that is 3 multiplied by 2 to 6.25, and then you would locate here, and then you would put in the value from the given class, so to get the next one. Okay. In similar way, you can do that yourself for deciles and percentiles. If you want to find a first percentile decile, so you will be considering taking n by 10, right? For second decile, you will be taking 2n by 10. For third decile, you will be taking 3n by 10. If you are interested in finding percentiles, so third percentile will be 3n by 100. First percentile will be simply n by 100. So the same idea, the rest of rule is straightforward if you want to use this formula. So for D1, for the first decile, this will be simply n by 10. For second decile, that will be 2n by 10, which is n by 5. The same thing for percentile. For the first percentile, you would simply use n by 100. The same n by 100 will be used here to find that percentile class, right? So I am leaving this as an exercise for the students who are basically watching these videos. Okay, the next measure is for certain tendency, that is known as the mode, which is the most easy one to be computed in central tendencies. Okay, so how do we define it? It is the score with the highest frequency of occurrence. In an observation which has a maximum frequency, that would be labeled as mode, or an observation which is repeated the most, that is known as the mode. And it is the easiest score to spot in a distribution, and this is again it is the only way to express the central tendency of a nominal level of measurement. Okay, if you have a nominal level of data and you want to find its central tendency, that is the mode which is used for it. Now, how do we do that? In case of ungrouped frequency data, the mode is simply the observation having maximum frequency. Okay, and in grouped frequency data, the model class is the class having maximum frequency after introducing class boundaries. Again, in this case, you would introduce class boundaries, and then a class with a maximum frequency will be considered as model class. And once we have a model class, in that case, we will use this formula, that is mode equals L plus Fm minus F1 by Fm minus F1 plus Fm minus F2 multiply by H, where L is the lower bound of the class, Fm is the frequency of the model class, F1 is the frequency of previous class, and F2 is the frequency of the preceding class. Okay, let's do an example. We are almost at the end of the lecture. So the following data give the speeds in miles per hour of 8 cars that were stopped on I-95 for speeding violations. So these are the speeds. So you see, in this case 77 is only one time, 74 is repeated 2 times, right? So 74 is what? That is the mode in this case. We can have more than one mode as well. Let's suppose if 77 was repeated, so in that case 74 and 77 both would have been the mode. We have more than 2 as well, we have more than 10 as well, etc. If no observation is repeated in the data, then there are 2 concepts usually used. Some statisticians say that there is no mode in this case, but some people say that every observation is the mode. Okay, so we do consider that every observation, because every observation is repeated. The most repetition is what? That is 1, so it is considered as a mode. So every observation would be considered as its mode. In case of ungrouped frequency data, what do? We simply consider an observation which has the maximum frequency. So in this case the maximum frequency is 4, which is 10. So the mode will be what? Mode will be 4. It's a very simple concept. Whereas in case of group data, we first introduce class boundaries. The same example we discussed for median, for quartiles as well. So we do same thing for group data and for mode as well. So in this case again you would introduce first class boundaries. So that's 29.5, 39.5. We don't need midpoints and we don't need cumulative frequency as well, because we are only interested in the maximum frequency. So you would introduce the class boundaries first, then the class which has a maximum frequency in this case is 304. So this class 59.5 to 69.5, that is what? That is the model class. So once we have model class, then we would use this formula which I explained earlier. So L in this case will be 59.5 and Fm is the frequency of the model class, which is 304. F1 is the frequency of previous class, so which is 190, divided by again Fm, which is 304. F1 is 190 plus 304 minus 211. Keep in mind this could be written in the form 2Fm minus F1 minus F2, or 2Fm minus then bracket, starting bracket with F1 plus F2. It could be written in a different way. And when you simplify this, what happens? We get 59.5 and this is 5.5. Okay, it's not 5.05, keeping in mind. And when you add this 5.5 to this one, that would give you 65.00 and then something. So mode in this case would be the number 65. If you remember, median was same 65 as well. Later on we'll be talking about that. What does it mean if mean, mode and median are same? So what would be the nature of the data? I hope it's clear to everybody. That's it from my side. Thank you very much for watching this video. If you have any question, you can simply post or drop a question in the comments box. I'll get back to you. If you want the video is helpful to you, share the same with your friends as well, such that they can take some benefit from this video. Thank you very much. See you in next video.